Now, when we're looking at transformations of trigonometric functions, before we start, I just want to review from the last course that when we're looking at sine and cosine, we're using the unit circle. So in terms of our unit circle, we know we start at 0, then we move to 90, 180, 270, and then 360. Now with sine, we start at 0, whereas with cosine, we start at negative 90. And then we make our way around our rotation. So what ends up happening for our key points with sine, we end up with our function for sine. And then when we're looking at our key points here we go. So we have 0, 0, pi over 2, 1, pi 0, 3 pi over 2, negative 1, and 2 pi 0. And then for cosine, there's our main points. So we have 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi 1. And then for tan, we won't really be using tan for transformations, but just so you can get an idea. So our key points here so we have 0, 0, pi 0, 2 pi 0, and then in terms of the graph itself, we have asymptotes at negative 1 and 1 approaching. So as I said, you may not use these. However, it's still good to have some of the key points. So we're going to describe the transformation that's applied to cosine. So we have m at x equals negative 1 over 4 cos 1 over 2 x minus 5 plus 6. So the first thing we notice here, there is a reflection on the x-axis. Our a value also tells us that there's a vertical compression by a factor of 1 over 4. So that's our a value. Next, we're going to look at our k value. Now remember, when we look at our k value, it's the opposite. So our k value is 1 over 2, which means there's a horizontal stretch by a factor of 2. And then lastly, we're looking at our d value and our c value, which tells us that we are moving 5 units to the right and 6 units up. Okay, so just like any other function, you describe a transformation starting with a, k, d, and then c. So we're going to write an equation for this transformation here. So there's a reflection on the x-axis, so we know it's going to be a negative a value. Horizontally stretched by a factor of 3. So if it's horizontally stretched, what does that tell us? So our k value is going to be a fraction, so 1 over 3. Shifted right 5 units, so d is 5. When we put it into brackets, it will be -5. And then up 12 units, so c will be 12. So what is that going to look like? So if we're applying this to, say, let's use tan. We don't use tan often. So we would have y equals -tan, and then 1 over 3, and then in brackets x minus 5, and then plus 12. So that would be our equation. Now on to the best part of transformation, sketching. So we are going to sketch f at x equals sine -1/2 x plus pi over 4 plus 2. We're going to state the equation of the axis. We're going to state the period of the function as well. And this is where knowing the key points is very important. So we're starting with sine. So we're going to write down our key points. You're going to use 5 of the key points. So the first point for sine we know is 0, 0. Then we have pi over 2 and 1. We have pi, 0. We have 3 pi over 2, -1. And finally we have 2 pi, 0. Okay, now if we take a look at what we're given, for our a value, we don't have anything for a, it's just 1. Our k is -1 over 2. Our d value is -pi over 4. And our c value is 2. So if we use x over k plus d and ay plus c for our new points. We're dividing by -1 over 2, so really what we're going to have, because we're dividing by a fraction, we end up with -2x minus pi over 4. And for our y values, a times y, so 1 times y, and then plus c, so plus 2. So take a moment. When you're working on transformations, the best tip I can give you is make sure that your denominators, you convert them afterwards so that they're all the same. The reason being, it will make it much easier to graph your function if the denominators are all the same. Okay, so after you've done the math, you should have -pi over 4, 2, -5 pi over 4, 3, -9 pi over 4, 2, -13 pi over 4, 1, and finally -17 pi over 4, 2. So notice all our denominators are 4, which is great. Our lowest value is -17 pi over 4. So let's go up by 2's here. So I'm just going to write the intervals here. So this would be -2, -4 pi over 4, -8 pi over 4. On this side, we have +4 pi over 4. I'm just going to keep going. And then our highest value is 3. So we can just go up by 1s. Oops. Okay, so how's this going to look? So we have negative pi over 4, 2. This is going up by 2's to a point here. Then 5 pi over 2 and 3. 9 and 2. 13 and 1. And then 17 and 2. So here's our transformation. Just make sure you make those points bold so we could see them. And then your curve doesn't have to be perfect, but you're just following those key points that you got. So our key points are here. Okay, so when you're sketching, make sure you use the key points. All of our key points are here. So you put your key points in the table, and then you're going to use the mapping formula to find your new x values as well as your new y values. So what would be the equation of the axis here? Our c value is 2, so our equation of the axis is when y equals 2. That'll be here. So it splits our function in half vertically. And then the period of the function, we know to find the period, we would have 2 pi over k. So in this case, 2 pi over 1/2, which gives us 4 pi. So the period, so one cycle is 4 pi.